Hi CJ Math students, and welcome to Notes 8.1. So today we're going to be talking about the Pythagorean Theorem. Again, that's pronounced Pythagorean Theorem. Later on in the unit we'll be talking about more specific angles. But kind of key idea is to find the length of one side when given two sides of a, and this is super important, right triangle. The Pythagorean Theorem only works with right triangles. So to find the length of one side when given two sides of a right triangle, we can use the Pythagorean theorem. Now, mathematically, the Pythagorean theorem is some relation of the three sides of a right triangle. It states that the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other two sides. I know I just said a lot there. So here we have a right triangle. I know it's a right triangle because I've drawn this right angle here. The Pythagorean theorem states that the side opposite the right angle, we label this the hypotenuse. The square of that is equal to the other two sides. We call them legs. All right, so if I were to draw another triangle, right, and this time I said my right angle was right here, the side that would be my hypotenuse is the side opposite the right angle, right, and then these two sides would be called my legs. All right. So, and just like we do with normal geometry or in algebra, we often assign things variables. And so as I kind of color in this, the Pythagorean theorem says that a squared plus b squared will be equal to c squared. Another way to say this is that one leg squared added to the second leg squared will be equal to the hypotenuse squared. All right. Now, in front of your desk, you should see a little square and square root charts. Remember, a number squared, like 2 to the third, is not 2 times 3, but 2 times 2 times 2. So a number squared, like 6 squared, is not 6 times 2, but 6 times 6. And this symbol stands for the square root, and it asks you a number times itself. What number times itself gives you that number. So, for instance, the square root of 49 is asking what number times itself gives me 49. In that case, it's 7. Or the square root of 81, what number times itself gives you 81? In that case, it's 9. All right. So let's do a couple of problems. I'll be asking you through Edpuzzle to do some of the your turn problems. So we're going to label this 1, this 2, 3, 4. So here we go. So again, the side opposite the right angle is always c. So in this case, c squared is x. So you can go ahead and say, all right, we need to solve for my hypotenuse. Now, a squared and b squared don't necessarily matter. You can kind of flip them around. So you can say that this is, okay, 6 squared plus 8 squared. All right, all we've done is plugged in these two sides as a and b, and now we're going to solve for c. So we got to do some algebra. 6 squared is 6 times 6, or 36, plus 8 squared is 8 times 8, or 64, is equal to x squared. All right, when we add 36 and 64, we get 100. So we're saying that x squared is equal to 100. So what does this mean? We need to find x, right? So to find x, we take the square root. Or we ask ourselves, what number times itself will give me 100? So x times x will give you x squared, and 10 times 10 will give you 100. And so your answer for the missing hypotenuse is 10, right? Number 3. So we'll start off by saying, okay, I have this right triangle, so I can use Pythagorean Theorem. So I have a squared plus b squared is equal to c squared. I'm missing my hypotenuse. This is my hypotenuse. The side opposite the right angle is always my hypotenuse. So c squared is that x squared that I'm missing. And I plug in 3 and 4. So 3 squared plus 4 squared. And now I do some geometry, or sorry, some algebra. 3 squared is 3 times 3, which is 9, plus 4 squared is 4 times 4, which is 16, is equal to x squared. 9 plus 16 is 25, is equal to x squared. And again, at this juncture, we're going to go ahead and take the square root, because we want to just solve for x. So x is equal to what times itself is 25, and the answer is 5. All right, that's it of part 1.